My name is Lia Robertson, and this is my Physics 1 lab at Georgia Tech, spring 2024. Table of contents. Overview, an overview of the lab, the equations used, what's happening in the videos computationally, experiment, graph of computer in my video, what if, a discussion of the results. Overview. Goal of Lab 1, to apply Newton's first law computations with vectors, analyze velocity graphically and computationally, and calculate position. Newton's first law. In our lab, we used the piece of Newton's first law that states an object that is in motion will continue to move unless acted on by a force not at equilibrium. Additionally, the law includes that an object not in motion will not suddenly become in motion unless an outside force causes it to do so. Newton's second law. When a system is acted on by an outside force, the system's acceleration is multiplied by its mass. This is also called the law of acceleration. Written as an equation, it is F net x equals ma subscript x. In this lab, the equations used in this lab include the following. In the GlowScript software, these equations were used. Note the arrow above some variables denotes a vector. The first line describes the GlowScript code, but it's a little bit easier to understand when written out. Written out, the first equation is the final velocity vector equals the final initial velocity vector plus F net over m times delta t. Additionally, the second equation written out is the final position is equal to the initial position vector plus the velocity average times delta t. Experiment. I used a small tennis ball and filmed a video of its motion. The tracker program produced a position versus time data, and the GlowScript program generated a simulated position versus time model that was perfectly exact. Here is my tracker video. For the prediction of tennis ball motion, we used the same equations as previously discussed and edited the following lines of GlowScript code. For the system mass, we left the ball mass to be 1, and for the initial conditions, we edited the position vectors to be 0.508 and 1.03 for the x vectors and y vectors respectively. We left the velocity vectors all as 0, and for the time, left t initial as 0 and the change in t as 0.17, which represents the size of each time step. We also kept t as less than 2.152 as that's when our data ended. Here, our graph describes the actual versus predicted results. The actual results represent our rolling of the ball, whereas the predicted results represent the computer model using GlowScript. What if? What if you flip the axes? The only difference would be a downward sloping graph instead of an upward sloping graph, which our data reflected. So what does this mean? Well, it means that the online GlowScript model is not 100% accurate. Things that we could do to fix this would be adding frictional force to the online model, using objects with a low coefficient of friction, and it's best to remember that net force is probably not 0 in this situation. Overall, in this lab, we analyzed a simulated model and compared it to our experimental calculations, both with constant velocity, and gained an understanding of Newton's first and second laws. Thanks for watching. Bye.